नमस्कार। आप सभी लोग अपने अपने घरों पर स्वस्थ रूप से होंगे तथा कोविड-19 से लड़ने की जद्दोजहद कर रहे होंगे। साथ ही अपने को सेफ रखते हुए अपनी सोसाइटी को भी सेफ रख रहे होंगे। इसी कामना के साथ हम बात करते हैं अपने अगले टॉपिक, दैट इज़ मॉर्फोलॉजी ऑफ द फ्लावरिंग प्लांट्स चैप्टर में हम बात कर रहे थे अभी तक स्टेम एंड रूट के। देन वी हैव टू टॉक अबाउट द मॉर्फोलॉजी स्ट्रक्चर्स ऑफ द लीफ, in which we have to talk about the structure of the leaf, especially as we can say generally the leaf is the lateral flattened structure, right, which can be borne on the stem, as well as we can see it develops at the nodes and bears bud in its axil evenly. We can say the axillary buds later develop into a branch and leaves originated from the shoot apical meristems, and we also say that they can be arranged in different ways, and the main role of the leaf is that they can be always helpful for the structures and for the photosynthesis of any plants. If we talk about the characteristics of the leaf, we generally say the leaf is a thin expanded green structure, and generally the green color of the leaf due to the presence of the chlorophyll pigment in it, and it is exogenous in origin. Means generally we can say the leaf is always grown on the plants is outbuilt outside. Evenly it has a limited growth, and we can say generally it does not possess the apical buds or the regular growing points. Then there is some different parts of a leaf. Means we have to talk about the different parts of the leaf that which can be seen easily from their morphological structures on any plant, right? First of all, we say the leaf attached to the stem branch is known as leaf base. Generally the part which can through which a leaf can be attached through the branch, that is known as leaf base. You can just see in the diagram easily. I think everybody understand about this one. Evenly we can say the another part in which we can say especially they can shows the another structures, right? This swelling structure, this that is called the pulvinus. Means we can say especially in the leguminous plants the leaf blade may be become solemn in that particular conditions, right? So generally in that conditions, as you can say, this is the special leaf base over here, and this swelling part, right, this is the part which we can say it is the pulvinus. As you have known the function of this pulvinus, especially in the mimosa pudinica, right? Means whenever the water turbidity can be decreases from this pulvinus, what will happen, the leaves can be closed up, right? Then we have to talk about another thing, that especially in the monocots the leaf base expands into a sheath covering stem partially to the completely. If you all have seen the maize plant, in which you can see this shows the especially a covering to different part to the stem of the plants. Evenly we can say leaves of the some plants possess a pair of the lateral outgrowths at the base. On the other side, the axillary buds, these outgrowths are called stipules, as well as the leaves can called the stipulate. Means stip is simply you can just see in the structures as in given over here, they can show the such structures. Means generally there are stipules and which can through which the leaf can be developed, that is called the stipulates. On the other hand, we can say the leaves without stipules are called the exstipulate, and with stipule, that is known as the stipulate. And we can say stipulates are generally green, and the main function stipulates are to be protect the bud at the carry out the photosynthesis in the plant one. Lateral other parts of the leaf, we can say the petiole or the mesopodium, right? Generally everybody is familiar with the petiole. Means before the lamina the leaf is attached to the different parts, that is called the petiole, in which we can say especially it can be the stalk of the leaf, right, and it can always help hold the leaf blade toward the light, and petiole raises the lamina high to the level of the stem, so the provided the maximum requirement exposure to the light and air. Means this petiole can always helpful for the supplying of these all laminas in the in front of the light and for the transpiration processes. Evenly we can say some other structures they can be shown. Means we can say petiole is usually cylindrical, but in it may be hollow in just like the papaya. If you have seen the leaf structure of the papaya, which can be attached to the plant, which can be whenever you can broken it, it is a hollow structure, tuber like structure in that particular condition. Evenly we can say the function of petiole is to raise the lamina to expose it more light and the air for the conduction of the different substances. The another that is called lamina or epipodium. Right? If we can say the petiole is known as mesopodium and the lamina that is called epipodium. We can say leaf lamina or the leaf blade is the same thing, which can have a green expanded part of the leaf with the veins and veinlets, and it has a permanent medium is called the midrib. Means generally it have a specific structures in its middle side that is called the midrib. As you can just see, this whole structure is called the lamina, and this one, this is called the midrib, and these are the veins, right? And these veins again have the small structures which are known as that is called the veinlets, right? So after that we can say they can be always helpful for the uh, leaf one. Only we can say these midrib can also produce the thinner lateral veins which can be turned back to the form the veinlets. Means as I shown in the diagram. And we can say lamina is the seat of the photosynthesis. Means this leaf lamina can plays a very important role for the photosynthesis. Means this leaf lamina can participate especially for the photosynthesis and exchanges of the gases and transpirations and other metabolic activities which are necessary for the plants, right? We can say the shape, margin apex and the surface of the extended Indian lamina varies from different leaf to leaf. Means such structures can be varies from one leaf to another leaf. Means this can be always shows the different structures in different plants. Then we have to talk about the venation of leaf. Means how the morphology of the leaf can show the special structures of the venation. As we can show that venation, first of all we have to know that what is the venation. Venation is a generally we can say the arrangement of the veins and veinlets in the lamina of the leaf, that is called venations, right? We can say the midrib veins and veinlets are contain vascular tissues, the xylem and the phloem for the conduction of the water, minerals, salts and the food in that particular plants. On the basis of this venations, the leaf can be classified into two categories, right? We can say especially the reticulate venation and the parallel venation. Means as you can just see in the diagram easily, with the help of this diagram you can understand about to know about the reticulate venation and the parallel venation. On the basis of this venation we can again classify these leaf or the plants on their categorizations, that is called the dicot category or the monocot category. So we talk about the reticulate venation. Means generally when the veinlets, right, form a network of venation is called the reticulate. Means as you can just see in the diagram that suppose this is the midrib, right, and the veins are both side of this midrib. In that particular condition you can know that this is known as the reticulate venation easily, right? You can just see in this leaf also it can show the such variations. Means veinlets and such structures can be shown in all over there in both sides of its symmetry, that is known as the reticulate venation. We can say generally this type of venation is found especially in the dicot plants, or we can on the other hand we can say in the reticulate venation the midrib is centrally placed and veins or veinlets remains distributed laterally, right, as I have shown in the diagram. On the basis of the number of the midveins we can say they can be again classified in different categories, right? It may be unicostate, right, as we can say, with a single midrib vein, as in mango. I think everybody has seen the leaf of mango, right? It can always shows a unicostate type of venation, that is a reticulate venation part. On the other hand, there is a multi costate, in which we can say the more than two prominent veins are found. That is, especially you all have seen a plant that is called Ziziphus, right? It may be, we can say, convergent or the divergent in different leaves, so on. Then there is another venation that is called the parallel venation. Means, as you all have seen the different, especially monocot leaves, especially we can say when the veins are run parallel to each other within the lamina, they can choose a venation termed as the parallel one, right? Especially we can say that it is found commonly in the monocotyledonous plants, as I have already told you. There are also two types, that is unicostate, means banana and Ghana, especially you can see they have the one main midrib, and then the both sides of parallel are veins are found over there. But there are some other, that is called the multi costate, in which we can say the grass, rice and bamboo leaves, they can show the such structures, right? So in that particular condition we can say they are also the parts of the parallel venation. So students, you must have learned about the structure of leaves, and these structures where you have learned about the types of the leaves one. Then we have to talk about the especially different types of leaf. Means we can say there are different types of leaves are found in our surroundings on the plants, especially in which we can say the simple leaves. Generally we can say the simple leaf, generally they have a single undivided lamina is called a simple leaf. If the lamina is not divided in that particular kind of leaf, we can say they are the simple leaf. And we can also think that the lamina of the simple leaf may be incised, but incision do not touch the midrib, right? Means they have incisions, means the outer parts of that lamina, should be not touched into the its midrib one. In that particular condition, we can also say that the lamina can be a various type of the incisions, which may be reached up to the half or more than half perimeter near the base of midrib. Such structure, that incisions structure can show this one. So we can say especially this region will not touch to its midrib one. So we can say such a structure is known as incisions one. On the other hand, the other leaf, that is called the compound leaf, right, in which we can say leaf when the incisions of the leaf blade goes down to the midrib, right? Means generally we can say when the this can be just felt under, or the incisions is always down to the midrib one, we can say, or to the petiole, so that the leaf broken up into number of segments called the leaflets, right? Evenly we can say the bud present in the axil of the petiole in the both simple and the compound leaves, but not into the axil of the leaflets and compound leaf. We can say generally these compound leaves include such structures, some different kinds of these structures, especially the different kinds. We can say the compound leaf pinnately or the compound leaf, right? We can say generally in this type of the leaf, the leaflets are the present in laterally on the common axis called the rachis, right? And which can represent the midrib of the leaf, like goldmohur and the cassia. Evenly there are four kinds of pinnate compound leaves, right? Means they can be in different other structures, as you can just generally seen in such a structures. The this is the main midrib, where the such leaves are can be arranged over there both sides, like this structure, that is we can say that the pinnately compound leaf. We can say as the leaves of incision lamina are discreted toward the midrib, which can be known as the rachis, and leaves are arranged into the both side of the rachis. This is the main rachis one, right? This is the main rachis over here in both sides of the these leaves can be also arranged in all conditions. So we can see such a, as you all have seen into the neem and rose tree, right? Then another one, the special kinds of structures. But before that, you have to know that the pinnately compound leaves are, as we can say, unipinnate, bipinnate, tripinnate, and D compounds. Especially as you can say, unipinnate as you seen in the diagram, then bipinnate as you can see in the diagram, this one, right, and the tripinnate like this one. If you can just see in unipinnate, after both side of branches there only was single leaf are found over there. In bipinnate you can say in after the branches there are two leaves can be found over there. In the tripinnate you can say the three leaves can be found over there in from arising from that particular place. There is another type of compound leaf that is called palmately compound leaf. Palmately compound leaf, you just imagine to your hand, right? Just open your palm and just you can see these all fingers are attached to their this palm one. So these fingers acts like a like the finger, acts like the fingers, or they are the leaves one like this. Suppose this is your palm one and these are your fingers like structure, right? So we can say the same structure can be found in on your hand also. So such structures, such they are known as generally the palmate compound leaf, right? Especially as you can see into the petiole as in the silk cotton plants one. So you can easily understand they are also again the same subdivisions, right? Unifoliate, bifoliate, trifoliate, right? I think everybody have seen the leaf of the bell patri, right? It is a trifoliate structure because there are three leaves are arranged to the particular simple structure. So such type of ways we can understand about the different types of leaf on the basis of different things. So you have to know about these leaves that they can be classified on the basis of the venation, on the basis of their structures, on the basis of their veins, right? So these and on the basis of their function also. So we can say generally structures can always helpful for the leaves that they take can be always very useful for the plant one. Tomorrow we will talk about the next topic that is the phyllotaxy, means how the different kinds of the arrangements is found in different plants, right? We will talk about that one and also about the function also of the leaf and some modification leaves and their functions. So students, you must prepare your notes with the suitable examples, with the suitable diagrams. Thank you.